Hey guys, today this is Statics Engineering, and in today's video we are looking at this motor winding. So this motor has four wires as the outlet, two inlet and two outlet. So let's start with our notes because we are now over the calculations of this motor. We are going to look at the number of poles. How many poles does this motor have? Next is the number. Now let's first go by the motor type, because by viewing it here you may hardly find out which kind of a motor it is. And then following the motor type, we are going to look at the number of slots, how many there are in here. You can count, but it's not a good idea to just count. Let's know how it is brought up, what brings it out. Then we have to know the number of running coils, because we have starting coils and running coils. And then we will look at even the wire size. It is very important. If you wind your motor with a different wire, the motor will easily burn out, or it will be hitting, and then when it hits, it will eventually burn or get destroyed. Next is number of starting coil. We need to know it also, because by viewing it, it is okay. Let me not hurry there. Then we even we have to know the direction, but with the direction you will know. Then number of poles, 4 poles, because you can easily determine that by the wires. You only count the wires, 1 2 3 4. Then the motor type, just because we already know that this is a 4-pole motor stator, that means it is a capacitor run motor. All those 4-pole rotors, stators, have a capacitor. So now I'm going to open here. We find out the rest together. So don't just hurry and equate this video before you learn anything. You have to be active, and then you have to watch this video from the start to the end, so that you don't miss out. Not forgetting to subscribe, give it a thumbs up. And now, after opening it up, we have the starting coils in between. But on reopening, I found that it is a 2-pole rotor motor. Yeah, these are 2 poles, because we have 1 pole, which is a 4 poles rotor. Yeah, 1 2 3 4. So now, number of slots, you have to know the number of coils within. So we have 4 coils, 1 2 3 4, 4 coils. Then we add on 4. You're right. So now we are going to add on more coils. Let me find out how many they are here. Now, since we are rewinding, we don't have to mind about the wires. Even if you damage them, no worry. But during the rewinding, you have to mind about the wires so that you don't damage them. But here the motor has already burned, so meaning we can do what we want. Then here we're going to count the number also. When you view outside here, you'll find that they are also number of slots. Yeah, that's what we are still finding. So we are done with the other one up, and then there is 4 here also. So 1 2 3 4. Opposite side, they are also 4 plus 4. Now these 4, 1 2 3 4 plus the 4 plus the 4 gives us 12. Then 12 multiplied by 2, you will get 24. you can try it also with your calc, but it is 24. Then 24 divided by 2, you will get 12. So our motor has 12 slots, has 12 coils. The number of slots is 24. So the number of slots is 24 slots, and then in the 24 slots we are putting in 12 coils. The wire size, now there is a number also of running coils. The number of running coils is 8 because we have 4 each sides, which give me 8. So it is 4 plus 4. Now the wire size is, this was 24. Yeah, this is 24. And then we are going to the number of starting coil, which is 4. I have already told you as I was calculating the number of slots. So the number of starting coils is 4. And then the motor, with the motor direction, 2, 3, 1, 2 the other side and do 2 opposite side. So they lie opposing each sides to the motor direction. Since this is a capacitor run motor, the direction differs depending to the connection. If you connect clockwise, it will run that side. If you connect anti-clockwise, that's why I say it is a both direction motor. So if you have this with you, then you have moved a mile towards motor winding, and once you move this, you will no longer fail, and this can even make your motor run smooth and you will not be disturbed. Now, checking over this tool here, I already have this video with you how it works. I'm even going to give you a card and you check it out, or a link at the end of this video. I will even give you the link in the description below, so you check it out. Now let's forge here, opening the opposite side because I was still on the connecting side. Now the bottom of our coils were still locked up. Then open, forge them, show you how to remove these coils from the slots. Don't forget to subscribe, give it a thumbs up, but not going away just because. If you go away now, you have left some ideas coming. So these are the woods that restrict our coil in the slots, and they even reduce on the expansion and contraction, because with that wood inside the wire, even if it expands, it reaches a point and the wood opposes it to increase on. Then here, just be active and you look at how you can easily remove the coil from the slots. Actually, I can even cut them off using a grinder or a hacksaw blade and pull from one side, but I never wanted to go by that idea, because even if you don't have a grinder or a cutting tool, you can still do motor winding. Motor winding is a fully manual work, so you don't need a lot of machines to do it unless you're doing it in a large scale. But for a small scale repair or production, you can do it manually. So when you push those wires in like that, you will pull the wires from one end and they will eventually get out of from the slot. So after getting off from one side, aim at the second side also and pull them out like that. Super easy, you see. And then moving to the next, because I don't want just to leave you hanging. I want you to view it very well here for the second time, and then we move to the next step. This is how you'll do it yourself. You see how I'm doing it here is how you'll do it there. Once you get it out like that, press it inside O and then pull from the opposite side. It will come out easily. Then after coming out, you squeeze and then go to the other second side, but there is a lot to do. Don't just go away, and then pull from the other side. Super easy. So motor winding is always easy. And then now here, when you get them out by hand like this, they will help you to do this. Check it out. When you have this with you, you can easily tell the coil spam, if you have this, or you can manually determine the distance in between using my tool. So now I'm going to show you that also. Using my tool, I will add just one pole, the movable point, and bring it near the rigid point and push in my coil. Then after pushing in my coil, I will again push the moving point away from the rigid point to acquire the distance in between. The distance in between is derived from here. So now here, it is easy to determine that this was my distance. And then you mark with a pen or a marker or chalk. But I usually use pens because they are so thin and they bring in the high level of accuracy. Super. So if I had cut them by a cutting tool, that was not going to be done like that. It was going to be manually. But if you need that process, just come in the comment box of any video of Talix Engineering. Ask, I'll give you those. Next here is the diagram. So I have already removed these slots 1, 2, 3, 4, and even opposite side 1, 2, 3, 4. So even if I draw my diagram here, 4 up and then 4 down. This is always done just to recall what was done. And then the positive pole is even here, the black wire. The positive pole was here. That is the positive pole. So I call it 1, and then I have the negative pole, which I may mark as 2. Then the positive pole, this is a parallel connection. This was a parallel connection. North pole, south pole, north pole, south pole, north pole. Then on this one, this is now my north pole, is going to the south pole. So we have a south pole, north pole, north pole, south pole, south pole, north pole, then north pole to the south pole. But when during winding, you have to make this one as 1. You don't have to connect, or you can connect. It doesn't matter. You connect and insulate. It will bring in it perfect. And then next I will then draw the diagram of the running coils. But before that, I have to dismantle, because I want us all to see what is being done and how you will do it also in the absence of the video. But it's better, I always advise you, if you have missed some points somewhere, you can replay the video so that you pick it out all. Then after removing the other first coil, it gives you the element, and you know, oh, this is it. So you see this black chunk here, this is where the motor got burnt from. Actually, a motor may even get it, you can even repair if you don't have enough wire or time. You can only fix in that burnt coil and leave the rest. If at all they are working perfectly, you can test by a multimeter. You can first check the continuity using a multimeter. You again check the resistance, that is in ohms. You will finally check the connectivity. When I talk about this is where the motor burned from. So the wire runs from there, from one point, and then the other one runs from one point of the opposite side. So meaning the opposite side will connect eventually. So let me draw it also. Oh, in my pen, yeah, right here. Okay, now I'm going to draw my circle, and then in between we have already labeled it for the starting coils. I don't need that, but I can only put in the lines to indicate that we have already used this. Okay, let me use the pen lead. And that then the middle part represents the starting coil, starting slots. We don't need that. We only need the running slots. So from that point to the center, they are 4 up, and then from the center to the bottom point, they are also 4. Then they are also 4 here, 4, and then again up they are also 4. Then I'm even going to draw in the wires how they run, because I've already shown you now the 4 empty slots have been removed. The 4 empty slots there, here. Then I'm going to, even here you can see 1, that is my number 1 wire, that is 1. And then at the opposite side of it, you can see that is 1, and then at the opposite side of it there is another wire also, which is wire 2. I've labeled it as wire 2. So the wire runs from one side and finishes it, and then runs back to the second side and finishes it as an output, because we need current to flow in a given organized direction, which will induce an EMF direction to rotate our rotor, and then the rotor will rotate with the aid of the ball bearings, and the ball bearings will connect to the pulley system and then drive our output. Yeah, right, sorry, that was just a simple way to go. Then where this blow side is this one, I'm holding this one coming this way. This is the blow side. So with the blow side I have 1. So from point 1 I'm going to, yeah, right, yeah, from point 1 I'm going to point 2 of the same coil. Then that same coil will turn back to the point 2 of slot 2, Then another slot 2 will run to slot 3 of the slot 4. The slot 4 will run to slot 6. The slot 6 will run to slot 7. The slot 7 will run to slot 8, like that. And then at the end of the slot 8, we have that wire coming out. As we jointed with the first starting coils, then that's going to be the same procedure. Beautiful. So here we bring in the other element of bonding. And remember, when you are bonded to someone, you lose your freedom. So these two coils are bonded to induce EMF, which will run. So doing all this all perfect, we are going even to measure our lamina. So people just rewind the motors minus checking the lamina. Sometimes the lamina goes below the resistance or sometimes above the resistance, scratches, damages, spines. So those all bring in chaos with motor winding. So we're going to solve all that. Good enough. We are together, and just subscribe if you don't want to miss any video coming out from Talex J Engineering. Thank you. And now, still with you. Sorry here with my camera. I may have not captured this, but I'm going to show it to you and explain what it means. As you see the slots up here, this is what I'm drawing, because I told you drawings will help you to recall how the connection goes, what to do, and remember easily. So my point 1, my point 2. Then these coils, as you see them up here, I've then drawn them down here the way they sit in their 8 slots. Then the remaining slots are also in the same element of parallel, but for them they vary the height or the distance in between. That's why I'm going to draw from the biggest to the smallest, and then again from the smallest to the biggest, because that is the connection with our motor. So have point 2 from point 2 to point 1, but they go on varying from the biggest to smallest, smallest to biggest. So the current comes in from 1 until it reaches point 2. So with this running coils, they have a difference, but which we are going to find out together. By finding out the difference, we have to pick out these wires. They are so easy to pick out. Don't fear, they look many but simple if you are taking time and consider what Talex told you. And with people who rewind these small motors, I grade them as the best engineers, just because they have a lot of work to deal with. First of all, they take in many wires. Secondly, they are so delicate, that is, you can easily damage it. Thirdly, they are so sensitive in a way that if you are not accurate, you may fail to fit in the wires. So with the big ones, it's a walkover. So if you learn this, you will have learned all. So please, even if you have been doing those big motor winding, try a small motor, that is like a sewing clutch motor, a washing machine motor, a blender motor, and a fan motor. That is where you will get enough experience. If you keep on with the big ones, yeah, good enough. I've given you an idea. So once again here, how to remove the slot, these coils from the slot. So please take few wires at a go. Don't pull it once. You will only pull it once, but organizing them, you organize one by one or a given group at a time. You see that? But with the pulling out, you will pull a given bundle, that is at a go, and it will come out. And then we are finally getting out our last slot. But I cannot just go away, but it is the same procedure. Few coils out at a time until you finish it all. You see how I'm selecting few coils at a time. If you can count them, they are around 5 to 8 wires, and then pull the whole coil out like that. Beautiful. Then after getting it out, we are going to count. But before we count, please, you can subscribe or give it a thumbs up if you like this video. During rewinding, we are going to fix new insulators, because these new insulators by now they have lost the properties, that is like they are no longer flexible. I do think others are damaged, and they are now rigid just because they are lacking flexibility. Looking at this, looking at these wires, this is where the motor started fading from, and then it even burnt actually this was the origin, and then it burnt this next coil. So now let's move on to count. So you have to count one by one up to the number that is that you find out, and then you count two of the opposite sides, that is to get the difference. So I'm counting, and that's why you are getting that silence just because I'm counting here. I don't want to mess up. So if I mess up here, I will be doing wrong. So guys, just during this time, you can take your time to subscribe or thumb it up, because I can't just keep talking as I'm counting. Okay, I have got out my number, which is now turning back to the notebook, because we have to note down. So I have this side, and this, what is left, it comes right on right. So after I counted the two slots, one left and then one right, I had that difference, and the difference is 5. So I had to go by 5 addition up to the biggest coil, or you can start by the biggest coil You count the big ones of the opposite sides, and then you go by the subtraction. If you count the short ones, you go by the addition. Then the coil difference is 5. It's also important because we have some other motors that don't have this difference. For them, they only have a uniform number. If it is 70, 70, it does not change or differ. And now we have also another trick, which is this coil, this motor, for it has a difference in size. But we have another kind of motors that don't have this, like the way you see the starting coils diagram. For them, they have the same size. So that's why I told you that this motor have 2 elements in one. So let me count here. Sorry for a silence, but I have to do because I'm counting. And then take this time to subscribe, like the video, and checking out the cards. You're right, this is now the first coil done. Then I have to go for the second one so that I get the difference. If you just count one, then you'll be doing wrong. Or you may even not count if you have enough experience, but if you're learning, no, count. So this one and the other one, I have got the difference, and the difference is 3. So here, even if you put in an extra by 1, it will not have an error. I didn't confirm this. Yeah, but even if you go by an extra 1, it will have no error. But here the difference is 3. So now I'm going to note the first and then the second, but they are all of the same length. So that's why I told you that earlier before that these capacitor motor runs, they have a lot to teach you. So if you wind this, you will learn a lot of things to do with motors. Okay, so we are soon leaving this video, but I don't think you can surely finish and leave me out without any subscription, because we are done with calculations, but we are going to wind, so you may need that video also from me, because me, I usually give full proof. I don't do videos to make fun. Me don't make fun, I just give full proof, because we all have to know these simple repairs, because they are so common in today's life. Now, how to find out if you don't use the other first format, let's use the other alternative of getting the coil length. So you have to get one wire. You can cut one from here, or if you want to reuse them, you may not cut. But what you have to do is get your wire, squeeze it in 2 slots, like the bottom slot and the upper slot, the way it will sit in during winding, and then organize it the way how you feel that now here it is fine and comfortable. Mark the point coil it very well so that it does not open, and then bring back your tool. So my point is where I'm holding, and then when I bring my tool back, I'll fit in, I adjust the point and fit it in beautiful like this. Then after fitting it inside, I will pull it far away and then lock the bolt below. So after locking the bolt below, I'll have already attained the real length of my coil. So this is also another idea how you can determine the length of your coil. So guys, nevertheless, you should not be challenged by motors, and if you don't have any problem now, you can give me a thumbs up or subscribe for more videos just coming in better than this one. Thank you.